Hi guys, today I'll be talking about staggered observations. A few of my subscribers have asked me to make a video on this topic here. I actually made a video on this topic, but I titled it Plotting the Ship's Position at Sea Using Position Lines Obtained from Celestial Observations. It was a big title, long title. Now I've retitled that one to Staggered Observations as well. And I will provide you with a link to that video as well with this video. So this video is another one, let's say, in that series, and this focuses on staggered observations. So if you don't know what staggered observations is basically two observations separated by an interval of time. Now what do I mean by two observations? So that means that you basically are referring to the measuring of the sextant altitude of a celestial body. So what you do is you normally take a morning sight and you use the sextant to get a celestial altitude of a celestial body, or the sextant altitude of celestial body. Then you obtain a position line, and then you probably come up to the noon passage or meridian passage time, and then you obtain another one in the form of a latitude. And intersection of two position lines gives you the position, or it could be different cases. I'm just giving you one example. You could also obtain two star sites or three star sites and get three position lines, intersection of which will give you the position of the vessel. So basically by observations we mean observations of celestial sextant altitudes. Alright, that's what I mean, if it sounds a bit weird. Alright, then that basically means that by the time you are getting these two observations, the ship's course and distance during this period also has to be taken into account in order to obtain the position of the vessel by combining the result of those two observations. So all this thing may not be making too much sense to you right now because it's all theory. Let me show it to you in the way of an example, and hopefully that will be more helpful to you. Alright, so let's go into the question. The question says that it's in DR position 4620 north and 11841 east. An observed longitude of the sun was obtained at 0800 hours. Okay, this is time, and found to be 11846 minutes east at an azimuth of 150 degrees true. A lot of information for you. So what is DR? DR is dead reckoning position. That means it's an estimated position, and you have a latitude and longitude here. Then you use the sextant altitude of the sun at 8 o'clock in the morning, and that means you use the long. When you say observe long, that means you use the long by Cron method. So this longitude here is your DR longitude. That means it's an estimated position, it's not the accurate position. But this longitude here may be more accurate because it's based on your observation of sun. Alright, and the azimuth of 150 degrees true. That means the bearing of the sun was 150 degrees true, and from this bearing we can get the position line by subtracting or adding 90 degrees. So if I subtract 90 degrees and I add 90 degrees, I will get a position line. I'll show all this what it means later on. This is just I'm trying to explain the question to you. The vessel then steamed a course of 238 degrees true. So you've got a course at a speed of 15 knots. So from 8 o'clock, once you obtained and observed long, you then steamed on a course of 238 at a speed of 15 knots. At 11:50 hours, that's 3 hours 50 minutes later from 8 o'clock, a latitude by meridian altitude sun was found to be 45 degrees 51.2. That means this is a meridian passage observation. So if you don't know these terms and you're not very familiar with it, please watch my other videos and I'm sure you will understand. So this basically means that about 11:50 you use the meridian passage method or the latitude by meridian altitude method of the sun to get an observed latitude of 45 degree 51.2 minutes. Alright, what you have to find is the position of the ship at the second observation. That means at 11:50 hours. So when I say second observation, that means at 1150 hours. If the ship continued on the same course and speed, what is the same course and speed? Course of 238 degrees true and speed of 15 knots per hour. You have to find the estimated position of the ship, or EP. Estimated position is called EP at 12 o'clock. That means 10 minutes later from 11:50. Alright, this is not based on observation of celestial bodies, this is based on estimation, based on course and speed. Alright, so I'll take you through the solution one by one. Hopefully it will be okay. So as I was explaining in the question, your time of transit, your initial time of transit from 8 o'clock to 11:50 hours is 3 hours and 50 minutes. So 8 o'clock was the morning sight, 11:50 is the meridian passage time of sight, right? And you are doing a speed of 15 knots. That means your distance traveled from 8 o'clock from 8 o'clock to 11:50 is speed into time. Speed was 15 knots and time is 3.833. What is 3.833? That means is 3 hours and 50 minutes. How do I get 0.833? You divide 50 minutes by 60 and 3 plus, like that. So you will get 3.833. Alright, so add 3 to it, you will get 3.833. Alright, 50 minutes also equals 0.833 of an hour. So 3 hours 50 minutes can be written as 3.833. Alright, times 15 is 57.5 nautical miles. So 3 hours plus 50 by 60 will give you 3.833, in case you were getting confused. Now you know your course was 238 degrees true, between 8 to 11:50. That can also be written as south 58 degrees west. How? Because if this is south and this is west and you are on a course of 238, which will be somewhere here, right? You are basically going south 58 degrees towards west. That's why 238 can be written as south 58 degrees west. Why we do that is because we have to find out on what course the ship is, so we can name our D lat and D long later on. So we know that a ship from a certain position is on a southwesterly course, so naturally we can name our D lat and D long. Alright, so let's start with the question now. So 8 o'clock your DR latitude was 46 degree 20 minutes north and observed long was 118.46. Now what you have to notice is this here. This is not your DR long. This is your observed long. Your DR long given to you is 118.41. I have not used the DR long. I have used the observed long because that is the more accurate long. Alright, 118.46 as you calculated here. Here. Again, I put an arrow here. 118.46. Use your observed long. Please take a note of this. Sorry about that. So take a note of this. This is the observed long, not the DR long. This is the DR lat. Alright, then I calculate my D lat. How do I get my D lat? Distance times cos, of course. Distance is 57.5 nautical miles that you calculated here earlier, and course is 58 degrees. You can also use 238. You will get the same value. Sometimes you get a negative sign. You can ignore the negative sign. Alright, so whether you use 58 or use 238, you get the same answer. Alright, so I'll put here, or 238 degrees, doesn't matter. Alright, ignore negative sign if any. Ignore negative sign if any. Alright, you get 30.5 minutes. Now this is not 30.5 degrees, cannot be, right? You have just traveled 57 nautical miles. So when you see anything less than 60 coming in your calculators, you should know it's only in minutes. 57 miles, you cannot travel 30 degrees. 30 degrees is 30 times 60, 1800 nautical miles. So when you see 30.5 in your calculator, that means 30.5 minutes. And that's why my D lat is 30.5 minutes here. My D lat is 30.5 minutes. And why is it south? Because remember, I am doing a southwesterly course. So that's where this south comes from. Alright, so when you are north latitude and you are going on a southwesterly course, your north latitude should decrease. So that's why I will subtract my D lat. And that's why my 11:50 DR lat is 45 degree 49.5 minutes. This is based on my estimation. So you can call this estimated lat and long as well. This is based only on course and speed. Alright, and then your D long. How did I get my D long? So once I get my two latitudes, I can find out my M lat. Because they are both in the same hemisphere, you just add the two latitude and divide by 2. Remember to use the DR lat in both the cases. One is 46.20, the other one is 49.5. Don't use your D lat by mistake, alright? Use the 8 o'clock DR lat and the 11:50 DR lat. So this is the 8 o'clock one, this is the 11:50 one. Then you add the 2, divide by 2, you'll get your M lat. And your M lat is north as well because you are of course in the north hemisphere. Once you get your M lat, you also calculate your departure by this formula. Distance equals sine of cos. 57.5 is the distance times sine of 58 or 238, doesn't matter. You will get the same answer. Ignore negative sign again if you get any. Alright, if any, doesn't matter. And that is your departure. Your departure is west as well because you are on a southwesterly course. And from departure and mlat, you can calculate your d long. Your d long is calculated by the formula departure divided by cos of mlat. Now these are all formula from the plain sailing. Alright, so don't think this is something new. If you have done plain sailing or just watch my videos on plain sailing, these are the same formulas. So you put the departure value, put the cos mlat value, and you will get your d long. Your d long is west as well, because again you're right, we are on a southwesterly course. So south is used for naming d lat, and west is used for naming departure and d long. Once you get 70.4, 70.4 also equals to 1 degree 10.4. Anything more than 60 minutes is now a degree. So if you get 70.4, just divided by 60, and you will get 1 degree 10.4 minutes. And that's why over here you have the d long of 1 degree 10.4 minutes. Apply the d long. Now you are on an east longitude and you are going westerly, so your east longitude should be decreasing ideally, right? So you will subtract it again and you get your dr long. Alright, so this can also be called estimated lat and long. Now remember, using this lat and long, you will start the plotting. Now I've drawn the plot for you already, but you don't know how I drew this plot, right? So that's why I've left some space for you, so I can show you how I did it. Alright, so you can see here, let me show you here, okay, and make some corrections here. Now this is observed long, so I will discuss. So I can call it observed long at 11:50, but this is still dr lat, so let this stay dr lat, right? Now you see this position here, so let me use a separate color pen. So you see this position here, this longitude here, and this latitude here, the blue one. You take this to latitude and longitude, and then you plot it in a plotting sheet. So if you want to plot it in a plotting sheet, just put a plus sign or a cross, that's it, and then you put your observed long here, observed long at 11:50, which is 117 degrees 35.6, and you put your dr lat here at 11:50, which is 45 degrees 49.5 minutes north. Alright, then you plot your position line. What is your position line? Remember, in the question itself it says here your azimuth is 150 degrees true, and I told you can get your position line by adding 90 and subtracting 90 to this azimuth. So if you come down here, your azimuth is 150 degrees true, or your bearing, add 90 and subtract 90 to this. What do you get? If you subtract 90, you get 60 degrees, and if you add 90, you get 240 degrees, right? That is the orientation in which you should draw a position line, 60 to 240. This should be going 60, 240. So you go 60 and 240 like this, okay? And you denote it by single arrows. Got it? So this orientation is 060 and this is 240. So the orientation of the position line becomes 060 to 240 degrees true. Got it? Now this is one position line. Intersection of two position lines will give you your position. So what is the second position line? So go back to the question and see what is your second position. And your second position line is this here, your meridian latitude, because this is also based on the observation of the sun as a celestial body. So 45 degrees 51.2 minutes north is what you have to plot. Got it? How do you plot this here? Now you know that this is 45 degrees 49.5 minutes north, and you have to plot 45 degrees 51.2. Now let's assume that you are doing on a plotting sheet. 1 centimeter equals 1 minute is the scale. So you know that you have to draw 45 degrees 51.2, but you know where 45 degrees 49.5 is, right? What's the difference? The difference is 0.7, 1.7 minutes. So if my scale is 1 centimeter equals 1 minute, I will go in the north direction, because that's where 45 degrees 49.5 will be. This will be measured 1.7 centimeters, which is equal to 1.7 minutes, right? Depending on your scale. My scale is 1 centimeter equals 1 minute. Okay, and I will stop here and I will draw a horizontal line. This horizontal line then becomes 45 degrees 51.2 minutes north. Alright, because I'm going north. If I had to go south, if my latitude would have been, my second observations would have been 45 degrees 46 minutes, then I would have gone south by 3.5 minutes, because I know my dr, this latitude, I know this dr latitude, so I have to draw my latitude in reference to this latitude. Alright, so because I have to draw 45 degrees 51.2 minutes north, which is going to be north of my dr lat, I will go north and use the scale of 1 centimeter equals 1 minute. I am only 1.7 centimeters or 1.7 minutes away. That's why I went north by 1.7 centimeters. And this becomes my second position line, my meridian latitude. My meridian latitude becomes my second position line. Intersection of these two position line gives me my observed position at 11:50. Alright, now I'll use a separate pen to show you what I did with the rest of the question. Alright, now what happens is this distance here becomes your departure. If you measure it by scale, and if I'm using 1 centimeter equals 1 minute, maybe you'll get 3 centimeters. This means departure is 3 minutes. And it's on the east side, it's on my east side, right? It's on the east side of dr and observed long. So it's on my east side of dr lat and observed long. You don't need to measure d lat because you know your d lat is 1.7 centimeters. You already know your latitude at 11:50. That is 45 degree 51.2. So this vertical distance becomes your d lat. Alright, so because you know both your latitudes, you can calculate m lat. Add the dr lat at 11:50 and observed lat at observed lat or meridian passage lat. Add the two, divide by 2, you get your you get your mean latitude. Then you can calculate your d long by dividing departure by cos m lat. Departure you calculated above using the scale, which is 3 centimeters equals 3 minutes, and then m lat you just now calculated as 4550.3. Divide your departure by m lat, cos of m lat, you get 4.3 minutes. Your departure and d long will be east because your observed position is east of the dr lat and observed long at 11:50. Alright, so then you apply your longitude. So if your dr longitude, or rather your observed longitude at 11:50, actually you can call it dr longitude because it was based on your estimated course and time, right? So don't get confused by all this, right? Because the morning one was an dr longitude, and then you got a observed longitude, and then you applied your course and speed, so that became your dr longitude. Okay, so don't get confused by all these terms. I'll show you why I think you guys will get confused. It's because, okay, here I will erase this now. Alright, basically this is your observed long, and then you applied your course and distance. So you estimate that this will be your longitude at 11:50. So I will use the word dr only here. Okay, so it doesn't confuse you. And then I will cut off this observed longitude. I will use the word dr longitude at 11:50. So you guys don't get confused. Alright, so I'll keep going now. So your dr longitude at 11:50 was 11735.6, which is here, and then your observed position, or your d long lies to the your observed position lies to the east of the dr lat and long. So naturally you are going further east, so you will add it. When you add it, you get your fixed longitude or observed longitude at 11:50. You know your observed latitude, which is the meridian passage latitude, 45 degrees 51.2 minutes north. So these two together gives you the position at 11:50. Alright, then the last part of the question that you have to find. So from 11:50 to 12 hours, so you have to find the position at 12 o'clock. So again, from 11:50 to 12 hours, you travel a distance of, at 15 knots, you travel a distance of 10 by 60. 10 is the minute, so 11:50 to 12 is 10 minutes, right? And you traveled at 15 knots. So that's why if I have to calculate my distance run from 11:50 to 12, I will calculate by 10 by 60, that will give me the minutes, that's the time of travel, and then 15 is the speed. So 15 becomes speed and this becomes time of travel, right? So you will get 2.5 nautical miles. Course is still the same, 238 degrees true or south, 58 degrees west. It's the same as above. Alright, so at 11:50 your position was this, as you have calculated from here. From here you put your position here, and then you calculate your latitude, dlat and dlong. How do you do that? So you see the method here. Dlat is calculated distance times course. Of course your distance is 2.5 nautical miles, course is 58 degrees or 238, doesn't matter, any one you can use, you will get the same answer. You get 1.3 minutes. It's called south because you are on a southwesterly course, as you can see. So you will name your dlat south, so you put your dlat here, south. And if I am on a southwesterly course from 4151.2 north, my latitude will further decrease. So my latitude at 12 o'clock will be 45 degrees 49.9 minutes. Again, this is EP lat and long estimated position because it's completely based on your projected course and speed, and that's why that confusion above. I didn't want you to confuse you because you were applying your projected course and speed to an observed long. So I didn't want you to think that it's actually an observed longitude. It was a DR longitude at 11:50 as well, right? But I didn't. I hope I didn't confuse you there. Alright, so your estimated position is always based on a projected course and speed, and observed position is only when you use your sextant altitudes to get a sextant site, alright, based on the celestial observation. Alright, now you get two latitudes. You can calculate the mlat, use 4151.2 and 4549.9, add the two, divide by 2 because they are both in the same hemisphere. You get your mlat 45 degrees 50.6 minutes north. Alright, then you calculate your departure using the formula distance times sine, of course. Again, distance is 2.5, sine is 58 degrees, course is 58 degrees or 238, you can use anything, you will get the same answer here as well. Ignore the negative sign again, like I told you. You get 2.1 minutes west because you are on a southwesterly course. Once you get your departure, calculate your d long using the formula departure divided by cos of mlat. Your departure is 2.1 minutes from here and mlat is 4550.6 from here. You get 3 minutes. It's west because your d long is west, your course is southwesterly, right? Take this d long and put back here, so you can see here. So from east longitude you are going west, so your east longitude should be decreasing, so you subtract it and that's your position. So this is your second answer. So position at 12 o'clock, this is the position. Alright, so I hope that was simple and I didn't confuse you somewhere in the middle. So just to make it very clear that you use your DR latitude and longitude and you apply your course and speed, then you get your estimated position lat and long, and then you can plot the position lines, and intersection of the two position lines will give you the observed position. Alright, so estimated positions are always based on a projected course and speed, and observed positions are based on the observation of celestial bodies. So I hope that was clear to you. If it's not, please write to me in comments which are the parts that was not clear to you. Sometimes when the question is so long and I'm trying to solve it with you guys, sometimes it gets confusing for you. So I hope it was not. Please write to me if it was, and I'm happy to address your doubts. And please watch my other video as well, that I have the link that I've put up with this video, and let me know if you have any doubts about that either. Alright, and thank you again to all my subscribers and my followers or people who watch my videos and comments. Really appreciate it from the bottom of my heart. Alright, so let me know what are the topics you want me to cover next, and happy to make videos on that. See you soon with my next video.